Today we'll be looking at 8.2, Cartesian equation of a line. So to begin our lesson today, just note the direction or inclination of a line can be described in two ways, by its slope and its direction vector. So what we learned yesterday about the direction vector. So the direction vector and slope. In the diagram here to your right, a line segment AB with a slope B over A is shown with a run of A, because it's always rise over run, and a rise of B. The vector, which is our direction vector, M, is equal to AB. Is used to describe the direction of this line or any line parallel, with no restriction on the direction number A and B. In practice, A and B can be any two real numbers when describing a direction vector. If the direction vector of a line is our vector M, AB, this corresponds to the slope M equals B over A, since B is your rise and A is your run. Except this will not exist when we have A equal to 0, because this corresponds to a vertical line, because if A were to be equal to 0, it does not exist, creating our vertical line. So now we will begin by looking at our first example. We want to determine an equivalent vector and parametric equations of the line y equals 3/4 x plus 2. So let's look at what do we actually know here. So we know that our slope is equal to 3 over 4. So therefore we know our direction vector M, which is equal to 4, 3. Because remember, our direction vector is equal to AB and our slope is B over A. And our point here, well, we know our point could be 0, 2, because this is just our y-intercept, right, which is 2. So determine the equivalent vector and parametric equation. So our vector r was just equal to our point, 0, 2, plus t and our direction vector m, 4, 3. Where here we have that x is equal to 4t, so looking at our parametric equations here, and y will be equal to 2 plus 3t. So that's our first example. Example 2, for the line with the equation r, with the vector r, equals 3, negative 6, and t times negative 1, negative 4, where t is an element of the real numbers, determine the equivalent slope and y-intercept form. We want to use two different methods to solve this. This will make sure that you guys are aware that you can solve it in two different ways. So, first way, let's look at it. Okay, so let's look at what we have here. We have our point, which is equal to 3, negative 6. We have our vector m, which is equal to negative 1, negative 4. So therefore we know our slope, oops, that should be negative 4 there, which is equal to negative 4 over negative 1, which is just equal to 4. So therefore, using our slope and our point, we have y equals mx plus b. And we know our linear equations. We've been doing this for a long time now, all of our high school careers. So we have negative 6 is equal to 4 times 3 plus b. So we bring over that 4 times 3, which is 12, becomes negative. So we get b that is equal to negative 18. So therefore our y is equal to 4x minus 18. Let's look at our second possible way to solving this. So what we have here is we can figure out what x and y are. So x, y, using our resultant vector here, 3 minus t, and we have negative 6 minus 4t. So therefore we have x is equal to 3 minus t, and we have that y is equal to negative 6 minus 4t. So using the above, we can say therefore that t is equal to 3 minus x. So just rearranging here. As well, we can rearrange, and we're going to get that t is equal to negative 6 minus y all over 4. Okay, obviously I skipped one step there where you need to divide both sides by 4, but you guys are in calculus, so I'm assuming we know how to do that by now. So 3 minus x, we can set these t's equal to one another. So that's where we get our 3 minus x is equal to our negative 6 minus y all over 4. Now I can cross multiply, bring that 4 up here. Make sure to multiply by both the 3 and the negative x. So we get 12 minus 4x is equal to negative 6 minus y. Rearrange. We get y equals, bring that negative 4x over to the right side, so we get positive 4x. Bring that 12 over, it becomes negative, and we get minus 18. So therefore you can see that both methods will give us the same answer. So now moving along here, we have example 3. Determine the Cartesian form of the line with the equation with the r equals 1, 4 plus s 0, 2, where s is an element of the real number. So Cartesian form. What is Cartesian form? Cartesian form is just our ax plus by plus c equals 0. So what do I know here? I know my vector m, which is equal to 0, 2. I know a point, which is equal to 1, 4. And we also, therefore, using our vector here, we can find our slope, so b over a, which is just equal to 2 over 0. Anytime you have 0, this is undefined, giving us a vertical line. So therefore, we can state that our equation, okay, is just x equals 1. Okay, so since it goes through that point here at 1, 4, so if we had this here and we had our point over 1 up 4, say that's our point, we know since this is a vertical line that x is going to be equal to 1. So you can learn how to develop the Cartesian equation from the direction vector and the normal on page 438 if you feel so inclined. So our Cartesian equation of a line in R2. In R2, the Cartesian equation of a line or scalar equation is given by ax plus by plus c equals 0, where a normal to this line is our vector n, which is equal to ab. A normal to this line is a vector drawn from the origin perpendicular to the given line segment to the point n, which is located at AB. So if I have my line here, okay, so I can say this is my line, okay, line 1. If I wanted to draw my normal to this, we start at the origin and we draw perpendicular. Remember, perpendicular means that we have a 90-degree triangle here. Okay, and this is our N, A, B. So now we can move along here. Now for example 4, we want to determine the Cartesian equation of a line passing through A, which is 4, negative 2, and has our vector n, which is our normal, at 5, 3 as its normal. Okay, so visually, what does this look like? So we can draw this out here where we have our normal. Remember, our normal comes from our origin. So if we locate the point 5, 3, okay, so that is going to be our normal here. Now we also know that it passes through the point 4, negative 2, sorry. Okay, so that's our point A. So if we're going to pass through, okay, we know that it creates a 90-degree triangle because it's a normal. So we also have our point P, which is located at x, y, because we don't know what that point P is. So we want to determine the Cartesian equation. Remember, the Cartesian equation is our ax plus by plus c equals 0. So our first step is, if we first look at our points, to think about this, I'm thinking about when they're normals and passing through certain points. Remember that when they are perpendicular, the dot product between the two would be equal to 0. Okay, so that's talking about the dot product between the two lines, and we don't know what AP is. So to find AP, what we need to do, we can say this is equal to x minus 4 and y plus 2. Okay, just from our knowledge of having to find out what the vector is itself. So therefore, we're going to find the dot product between AP and 5, 3. So x minus 4, y plus 2, and the dot product with 5, 3. And we know it needs to equal 0. So therefore, we have 5x minus 20 plus 3y plus 6 is equal to 0. So therefore, we get 5x plus 3y minus 14 is equal to 0. And that's actually just our Cartesian equation there. But let's look at our second way too. So we have our normal, which is our AB. Okay, we know that our Cartesian plane, our Cartesian equation is ax plus by plus c equals 0. We also know our vector n, which is 5, 3. So therefore, since we know our vector n, we know this is going to be 5x plus 3y plus c is equal to 0. Then we can sub in our point that we know, which is located at 4, negative 2, since it passes through that point. So when we sub that in, so 5 times, sorry, that should be positive 4 there, plus 3 times negative 2 plus c is equal to 0. So therefore we get 20 minus 6, okay, plus c is equal to 0. 20 minus 6 is going to be 14. And then when we bring that over, so it would be 14 plus c equals 0. So therefore c is equal to negative 14. And therefore our Cartesian equation is exactly the same, 5x plus 3y minus 14 equals 0. So looking at the parallel and perpendicular lines and their normals, if the lines L1 and L2 have normals N1 and N2 respectively, we know the following. First, we know that the two lines are parallel if and only if their normals are scalar multiples. So therefore, it's just stating that our normal 1 is equal to our scalar k times our normal 2, where k is an element of the real numbers and k is not equal to 0. It follows that the line's direction vectors are also scalar multiples in this case. The two lines is our second thing, thing that we know here. The two lines are perpendicular if and only if the dot product of their normals are 0. So therefore it follows that the dot product of the perpendicular lines is also 0. So perpendicular lines is also 0. Okay, it shows you here your two parallel lines. Okay, so we have our two parallel lines and our two perpendicular lines. So you notice that we have our line 1 and our line 2 that are parallel, and our normal that is running through them. Here we have our lines perpendicular to one another, as well as our normal axes perpendicular to one another. So using the above information, for example 5, we have two parts. We want to, part A, we want to show that the lines L1 and L2 are parallel and non-coincident. So if they're non-coincident, that means that if the equations are scalar multiples. So what we are going to do here, okay, looking at our line 1, we know our normal to line 1 is just 3, -4, okay? And our normal to line 2 is equal to 6, -8. Looking at these two, how can I get from 3 to 6? That's right, I can multiply by 2. And how can I get from -4 to -8? Again, I can multiply by 2. So therefore, I know that my normal 2 is equal to 2 times our normal 1. However, are they non-coincident? So that means, is line 1 equal to line 2? So we need to see this. So now what we do is we look at our C values, okay? So looking at our C values, if they are the same line, if we multiply that -6 C value times 2, if they're the same, we would get the same C value in line 2. However, we get -12. And -12 is not equal to 12, so therefore we have shown that they are parallel by showing that they're scalar multiples, and non-coincident by showing that they are different values for your y-intercept. Now for B here, for what value of K are the lines L3 and L4 perpendicular? So if they're perpendicular, we know that the dot product is going to be equal to 0. Okay, so the dot product of the normals. So I have my normal for line 3, which is equal to K4. And we know my normal for line 4 is equal to 3, -2. So doing the dot product between the two, we know will result in this equaling 0. So therefore we have 3K minus 8 is equal to 0. Rearrange, we're going to get K is equal to 8/3. So therefore, for the value of K equals 8/3, the line 3 and line 4 would be perpendicular. Now, example 6, we want to determine the acute angle formed at the point of intersection created by the following pair of lines. So we have line 1 and line 2. So what we're going to do here, we're going to go ahead and graph these. So our line 1, okay, is xy equals 2 plus s -1, -3. So here we can find what my slope is for line 1. So my slope is just equal to our b over a, okay, so it's just equal to -3. Line 2, so what that means is our rise is -3 down over 1 to the right. And my slope for line 2 is just equal to 4/3. So I'm going to first go ahead and plot my point, 2, 2. So over 2, up 2. Okay, so that's my point for line 1, and then I'm going to do my slope. So down 3 over 1. Okay, so I have my point here. So what I'm going to do here is I'm going to now connect those. Okay, so we have a little bit of pink going on. Make sure that we draw arrows at the end here, and this is our line 1. And then our line 2, alright, our point is 5, 1, so over 5, up 1, okay, and our slope is up 4/3, so what I'm actually going to do is that I'm going to try to get to the point 1 before. So I'm going to go down 4 and left 3 because I know it's a positive slope. So I know that I need to get from the point on the left hand side to my 5, 1, I just need to do work backwards here. So down 4 over 3. So our point is going to be there. I'm going to draw another line here. So let's do that one in blue here. And we're going to connect those. Okay, and that's going to be our line 2. Now the point of intersection here, the acute angle that's formed, is this angle right in between here. Okay, and since these are intersecting lines, I know that those two thetas are going to be equal to one another. So what we have is that we have our vector A and our vector B. So A is equal to our negative 1, 3, and our vector B is equal to 3, 4. So we know that we need to, the dot product between the two is equal to the magnitude of the two multiplied times our cos theta. And we want to find what our theta is equal to, so we can rearrange here so that we have the dot product between the two vectors over the magnitude of the two vectors. So to do that, we need to know the magnitude of A, which is just the square root of negative 1 squared plus 3 squared, which is just the square root of 10. And the magnitude of B would be equal to square root of 3 squared, which is 9, plus the squared of 4, which is 16. So 16 plus 9 is the square root of 25, which is a perfect square, which is 5. So now we do the dot product between A and B. So that's negative 1, 3, and the dot product between that and 3, 4, all over root 10 times 5. And what we're going to get here, I'm just going to continue up here, we would have negative 3 plus 12 over 5 root 10, which is just equal to 9 over 5 root 10. So therefore, to find theta, you need to do the inverse of cos, and what we get when we do that is we get theta is equal to 55.3 degrees. Okay, there is a decimal there. I know it's hard to see with the image there. Sorry about that. So now what I would like you guys to do, I'd like you to go on page 442 and do the investigation. Now it says on your sheets, do A and B in class. However, in class is at home for you. So I'd like you to do investigations A and B at home, okay? And then in class you can do C to G. If you're feeling up to it, please go ahead and do C to G at home as well. More time in class to complete the remainder of the homework. And that's our lesson for today.